First, we have the agarose gel, which we made before, and we're going to put some TE buffer in it in order to let the DNA run throughout the course of this process.
And then I'll take the DNA that is labeled in my Eppendorf tubes and prepare to pipette it into the gel. Once we have our DNA labeled and placed in the Eppendorf tubes, it's time to dye with the loading dye in order to see its progression through the gel. Notice how I'm pipetting very deeply and very quickly and carefully. This is so that no excess DNA with the loading gel escapes, which could make the gel murky and ruin results. Now we'll attach the gel and its apparatus to the power supply. This will allow us to run the gel from negative to positive, which will cause the strands to extend as far as possible and will give us the clearest reading on the gel. Now we have to choose a voltage on what we want our power supply to run on. In this case, I'm going to choose 60, but you can range from as high up as 400 to as low as 20. It all depends on how fast you want the gel to run. Higher numbers may yield faster times, but may yield more inaccurate results. Once we see the bubbles, we know that the voltage is working and that the gel is running. The black side will have more bubbles since it is the positively charged side, and the red side will have less bubbles since it is the negatively charged side. Now we can see our gel is really starting to run. The various kb lengths are being separated by the gel, with the longer ones moving less of a distance than the shorter ones. This easily divides up our primers and our vectors and allows us to cut them out and freeze them for further experimentation or cloning. So how is gel electrophoresis useful to a biology professor? Well, every bio professor's lab has at least one gel electrophoresis machine with a power supply. The sheer importance of these can't be understated. The ability to take a plasmid and a vector and separate the two into their DNA segments and see whether the plasmid bound to the vector, producing a helpful expression, is priceless. This allows us to discern between the vectors that did not pick up the plasmid and did not receive the gene expression and those that did. Then we can clone that gene expressed in bacteria such as E. coli and multiply them while creating a protein that humans can use. Gel electrophoresis is one of the key skills that is needed in any biolab. If you know how to do it, you have a place at any lab, anywhere in the world.